So why are ions formed? So ions are formed for one singular reason, and that reason is for stability. Okay? So for an atom to become stable, it must have a full valence energy level. Okay? Now, if you do not know what I'm talking about here, let me explain this using the Bohr-Rutherford model, right? Which is a way to represent electron configurations. Okay? So let me just use red for that. And I'm going to just use the example of carbon. Okay, so 6 proton, 6 with 6 proton, 6 neutron, and this is our energy level, right? So we're gonna have 2 on the first one, right? And then we can have at most 8. In this case, we're only gonna have 4 because we had 2 here. So if we do 1, 2, 3, 4, 5, and then 6, right? It is going to be 6 electrons, and the reason why it's 6 electrons is because it's currently in its atom state, and atoms are neutral, right? It is ions which have charge, and therefore, since it's neutral, 6 protons, is our positive charge, right? We should have the equal amount of negative charge, right, which is our electrons, and that way they both cancel each other out. Okay, pretty simple stuff. But yeah, now, the issue with this electronic configuration is that it is not stable. And the reason why it's not stable is because the outermost shell, right, which is this one here, right, this one here, right, that is not a full energy level. And the reason for that is, as I stated, it's the first level, which is supposed to only have 2, and afterwards it's going to be 8 valence electrons until like 21 proton count, then something else happens, but we don't need to worry about that, right? What we need to just know is that this is not a full valence energy level or outermost level, right? You could also call valence outermost, right? Valence is just more technical term. So the reason why it's not full is because it only has 4. This energy level by itself only has 1, 2, 3, and 4. They're called valence electrons because they're in the valence energy shell or level, and that's the outermost, right? And for energy level to become stable, as I mentioned, it has to have 8 valence electrons. So what we need to do actually is we need to add valence electrons, all right, so that it reaches 8 valence electrons, right? So we would just do that like this, right? I'm just using a different color. It's still like a regular old electron, but I'm using a different color to show you that those are the new ones added, right? Now, this carbon atom has become an ion, first of all. And the reason why it's an ion is because now it has a charge. And the reason why it has a charge is because the positive and negative charges, right, they're imbalanced. The amount of negative charge is higher than the amount of positive charge because these electrons represent, negative charge, right? All right. So this way, we literally just created an ion, right? Because of the fact that for an atom to become stable, right, it needs to have a full valence energy level. And so to get a full valence energy level, we have to add or also subtract valence electrons, right? And by subtracting or adding valence electrons, we're altering the amount of electrons in a given atom. And therefore, it could either be higher, right? Or the negative charge can be higher or lower than the positive charge, but in both scenarios, the positive and negative charge are imbalanced, right? Which causes a charge within the atom, right? Which again becomes an ion. Okay, so that is why ions are formed, right? Now, another important question to ask ourselves is how do we determine an element's ionic 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 charge? Okay, so what do I mean by this? Well, an ionic charge simply means you can think of it as how many atoms or the number of, sorry, not atoms, but the charge, I should say. So, sorry, I'm going to rephrase it. So, ionic charge simply means the charge which will lead stability, right? I'll just write stable. but means stability. But yeah, so essentially the element's ionic charge is the charge which will lead to stability, right? So to get the charge, right, we have to actually look at noble gases. So now noble gases is a family of elements, and they are completely stable by nature. So their atomic form, right, or neutral form, it is stable, meaning it has a full valence shell, right? And we can actually see that if I look at my periodic table, helium has two atoms, right? Sorry, two protons. So that means it would have two electrons in its atom, in its atomic form, right? And since it's the first shell, it's in the first energy level, right? Because you need a maximum of two. And then if there's more than two, you'd move on to the next energy level. But since there's only two right now, you're still in the first energy level. And two is enough to be considered a full outermost shell because the first level is always going to have two, right? Same thing with neon and, going further and further, right? So, as I said, noble gases, they're stable. That's what I was trying to prove with my analogy. Okay? Now, what we can do is we can actually use noble gases and find the closest one in terms of electron count. Okay? So in terms of electron count, it is expressed by the atomic number, because again, we're looking at the atomic form of these elements, right? What we can do is we can find the closest noble gas that is relative to our electron count. So in the case of carbon, right, that would be 6 electrons in its atomic form. So we're assuming that this is an atom, right? So it's gonna have 6 electrons, all right? And since it only has 6 electrons, all right, all we need to do is we need to find the element, right, with the closest amount of electron count, right? And the way that we can do this is by just simply looking at the periodic table. So there's 6, right? So all we need to do is we need to just look at our periodic table, and we'll notice that neon is the closest because it has 10 proton or atomic number, and that is the closest you can get with carbon. All right. So all we can do now, or all we need to do now, is we need to just do 10 minus 6, and we'll get 4. So that means that we need to add 4 more electrons, right, to our atom for it to be considered a stable element. All right. And by doing this, we're actually doing a negative charge, so it's going to be -4 charge. The reason for this is because since we're adding 4 electrons, that electron actually represents a negative charge, and since it represents a negative charge, if you add 4 negative charges, that's actually a charge of -4, right? But yeah, that's how you are able to determine, right, the ionic charge of an element. All right. So here we learned why ions are formed. That's because of their stability, and we also learned how we can determine their ionic charge.